Hi guys, today we're going to talk about specific heat. And this is a very important topic when we are studying thermodynamics and physical chemistry. So on this video, we are going to discuss what is specific heat. And we will be explaining that every substances have different specific heat and what does it mean if you're having this value in specific heat. Okay, so we're going to derive the equation for specific heat, which is Q is equal to mc T2 minus T1. And then basically one of the usual questions na ma-encounter natin in studying thermodynamics and physical chemistry is yung term na heat capacity and specific heat. So what is the difference between heat capacity and specific heat? And then after that, we're going to apply yung mga natutunan natin by answering these two problems involving specific heat. And then right after that, we're going to explain the specific heat in different conditions at constant volume and constant pressure. Then we are going to discuss the relationship between Cp and Cv. We're going to derive that equations as well. And then we're going to show you the internal energy of an ideal gas and the enthalpy of an ideal gas. Then after that, we're going to apply yung mga napag-usapan na natin in answering this last problem here. We have problem number 3 in which we will be solving these 3 requirements. We're going to get the value of Cp and Cv with given R and yung ating ratio. And then we will be solving further by using ideal gas law. Okay? So, as you can see, we will be applying yung mga matututunan natin dito sa ating topic in specific heat, yung mga na-derive nating mga equation. We're going to use that in answering problems doon sa bandang dulo, no? So, I hope this video will be helpful to you because you will be encountering a lot of terms and application when you are studying thermodynamics and physical chemistry. So, hindi na natin patatagalin pa. Let us now jump to our discussion. Okay, so suppose that we have here 2 beakers. One is containing water and the other one is containing oil. And they are both having the same mass or same amount of water and oil in their specific container. So they have same mass and they are heated with the same amount of heat. Now, if you put a thermometer on these 2 beakers, you will find out that the oil is heating faster than the water. So, our oil is heating faster than the water. Okay? Well, that is because water has a different specific heat capacity to oil. So, ano ba itong tinatawag nating specific heat? The specific heat of a substance is defined as the quantity of heat required to change the temperature of a unit mass through 1 degree. Okay, so different substances have different specific heat capacity. Katulad nung ipinakita natin kanina dito sa ating example. Although pareho yung kanilang amount at pareho rin yung in-apply nating heat, yung isang material natin will heat up faster compared to the other one. Have a look at this table in here. So as you can see, yung water, yung ice, and steam, they are all water in different states, right? But in spite of that, they have difference in specific heat. Water has a higher specific heat with 4.184 joules per grams degree Celsius. Ice have 2.03 and steam has 2.01 joules per gram degree Celsius. So ano ibig sabihin yan? It means that if the material is having a higher specific heat, it has more capacity to take heat. So therefore, mas matagal mag-i-increase yung temperature. So comparing water sa ice, mas kaunting heat lang ang kakailanganin to change the temperature to 1 degree compared to liquid water in which it will take about double ng heat capacity, no, ng ice. That is why if we're going to check this phase diagram of water, as you can see the temperature versus heat dito sa ating diagram, mas makikita natin na mas mababa yung slope ng ating liquid phase water compared to solid phase and the gas phase. It is because it will take longer time for our water in liquid phase to change in temperature compared when it is in solid state and in its gaseous phase. The same for different types of metals. As you can see, aluminum here is 0.897 and iron is 0.449. So, aluminum has a higher specific heat compared to iron. That is why mas matagal mag-heat ang aluminum compared sa iron. Because aluminum will need more heat compared to iron to change its temperature by 1 degree. Okay, so basically, what we are trying to say here is that kapag mas mataas ang ating specific heat, mas matagal mag-change yung temperature ng ating substance, no? Because it will be needing more heat or heat energy compared to other substances na mas mababa yung specific heat capacity. Okay, so yun yung mga bagay na kailangan nating tandaan. So let us go back to the definition of specific heat. Well, according to our definition, the specific heat of a substance is defined as the quantity of heat required to change the temperature of a unit mass through 1 degree. So, let's say C is our specific heat. So, it is saying, according to our definition, that this is the amount of heat. Okay, so this is an energy. Okay, so this is the amount of heat that is required to change the temperature. Okay, so per change in temperature, okay, of unit mass through 1 degree. So, for every mass. Okay? So, basically, that is what we mean ng specific heat. The energy or the heat energy required to change the temperature of a unit mass through 1 degree. So, in differential quantities, we could also write this as C is equal to the amount of heat, which is the change in heat per unit mass and the change in temperature. Okay, or we could write this as dQ is equal to mc dt. And solving for this differential equation, okay, we are going to take the integral of both of our terms. And then, if we are talking about a particular mass m, so our mass will be constant. So, we will have Q is equal to mass from state 1 to state 2 times C dt. Now, if the mean or instantaneous value of specific heat is used, so therefore our C will also be constant. Okay, so our Q will be equal to mc, then the integral of 1 to 2 dt. So finally, our Q will be equal to mc delta T or T2 minus T1. Okay, so this is our formula for the specific heat. So, ang madalas nating maririnig is may tinatawag tayong heat capacity and specific heat capacity. So, ano yung pinagkaiba nilang dalawa? So, let us try to differentiate them, no? So, in here we have heat capacity. And then here we have the specific heat capacity. Okay? So, just for the sake of our representation here, so let's say our heat capacity is CH. And for our specific heat, we have CSH. Okay? So, this is just for reference, for identification lang, no? Now, the heat capacity is equal to the amount of energy that is either changed or absorbed or released for every change in temperature. Okay, so that means ang magiging unit natin dito is joule, which is an energy for our heat over the temperature degree C or joule per Kelvin. While in our specific heat, this is the amount of energy change which is either absorbed or released for every particular mass and every change in temperature. So therefore, ang magiging unit natin dito is joules per gram per degree Celsius. Okay? So as you can see, meron tayo ditong denominator na unit mass. That is basically the difference between the two. In heat capacity, it depends not only on the identity of the substance but also on the mass of the sample. So anong ibig sabihin nun? It means that in here, if our mass increase, okay, so nagkaroon tayo ng pagbabago sa ating mass, our mass increase, in that case, our heat capacity will also increase. So kung makikita ninyo, heat capacity is an extensive property because it depends on the amount of material present. While dito sa specific heat, it is not dependent on the amount of material. So kahit na mag-increase ang ating mass, our specific heat will not change. So for example, you have water as our substance. So regardless if you have 200 grams of water or 100 grams of water, the specific heat will be the same. Okay, so yan basically yung pinagkaiba ng heat capacity sa specific heat. Okay, so let us apply itong natutunan natin. We learned about specific heat. This is our equation na derived. So let us solve this problem here. So in problem number 1, we have how much energy in joules is released when 650.6 grams of iron metal is cooled from 456 degrees Celsius to 22 degrees Celsius when the specific heat of iron is equal to 0.444 joules per gram per degree Celsius. Okay, so we're going to use yung equation na na-derive natin. Our Q is equal to MC delta T. Okay? So, ang hinahanap natin dito is yung amount of energy in joules. Okay? So, therefore, we are looking for our Q. And given ang amount or mass ng ating iron. Okay? So, we have here 650.6 grams. Then, given ang specific heat ng ating iron, which is 0.444 joules per gram per degree Celsius, and the change in temperature, which is from 456 minus 22 degree Celsius. Okay? So, we're going to solve this, pero check muna natin yung ating mga units. Our grams will be cancelled and our degree Celsius will be cancelled out. Okay, so let us use our calculator. So we have 650.6 times 0.444 times our temperature, which is 456 minus 22. Okay, so this is equal to 125,368.02. Okay, so we have 125,368.02 joules. So this is our answer for problem number 1. Okay, so now let's go to problem number 2. And we have here this question. It takes 30 calories of energy to heat 13.6 gram sample of an unknown metal from 18 degrees Celsius to 49 degrees Celsius. Determine the specific heat capacity of the metal. Okay, so given yung ating energy Q, which is 30 calories, no? So let us convert this first into joule, okay? Because we will be deriving our heat capacity in a unit joules per gram per degree Celsius. Okay, so our Q on this case is equal to 30 calories, and we're going to convert that into joules. So in every 1 calorie, we have 4.184 joules. Okay, so our unit for calorie will be cancelled out. So, ang may iwan sa atin is the unit in joules. So, let us calculate for that. So, we have 30 times 4.184 which is 125.52 joule. Okay? So, yan yung ating Q. Now, our Q is equal to MC delta T, yung na-derive natin kanina, no? So, our Q is 125.52 joules is equal to the mass of our unknown metal, which is 13.6 grams. Then, we don't know the specific heat capacity. So, we don't know that. Ito yung ating hinahanap. Then, our temperature has changed from 18 degrees Celsius to 49 degrees Celsius. So, we have here 49 minus 18 degrees Celsius. Okay? So, we have our C is equal to 125.52 joule over 13.6 grams over 49 minus 18 degree Celsius. Okay, so we can now solve for our specific heat capacity. So let us use again our calculator. So we have 125.52 divided by 13.6, then divided by 49 minus 18. Okay. Okay, so we have 0.2977 joules per grams degree Celsius. So this is our answer to problem number 2. Okay? Alright, so now we know how to solve problems involving specific heat. Now, you will encounter our equation expressed in different way. If we have a constant volume specific heat, you would see our equation as Q at constant volume is equal to the mass times the specific heat at constant volume. So, makikita nyo may CV tayo dito. So, our specific heat at constant volume is CV. Okay? And this is multiplied to T2 minus T1. So, as you can see, pareho lang naman yan ng ating equation dito, no? Kaya lang, kapag nasa constant volume tayo, our heat capacity here, our specific heat here will be CV. Okay? So, that is why we have here QV is equal to MCV times T2 minus T1. And the same way, if we have constant pressure process, our Q at constant pressure is equal to MCP T2 minus T1. Okay? So, CV is our specific heat at constant volume and CP is our specific heat at constant pressure. And if you take the ratio of our CP to our CB, we will have our K. Our K is equal to CP over CV. And this value is greater than 1.0 because our CP is greater than CV. Okay? So we have to take note of that. So let me write this properly. We have CV here. Okay? Okay, so we need to take note of this ratio because we will be using that in calculating CP and CB because sometimes CP lang ang given, sometimes CV lang ang given. So you can get that by using this ratio right here. So, okay, so now let us have a closer look yung relationship ng CP sa CV. Okay? Now, we learned from our previous lesson about enthalpy that enthalpy is equal to U plus PV, right? And for ideal gases, we also know that PV is equal to RT. Okay? So, we are working on specific mass here, kaya we omitted yung mass. Okay? So, therefore, we can substitute itong ating PV for ideal gas dito sa ating equation, no? And if we differentiate that, we will have DH is equal to DU plus R dt. Okay? Because our R is constant and here our temperature is changing. Our H here, okay? Our DH here is delta H and this is equal to MCP T2 minus T1. I'm going to show you later paano natin nakuha yan. And our du, which is delta U, is equal to mCv T2 minus T1. I'm also going to show you paano nakuha yan, ano? Okay, so we're going to substitute this dito sa ating equation dito. But again, we are talking about specific mass here, so I'm going to omit that. So as you can see, it will be cancelled out anyway, no? Kaya hindi na natin yan sinulat. So our delta H is equal to Cp dt. Inalis na natin yung m. So Cp delta T, no, is equal to our du, delta U, which is Cv dt, and plus R dt. Okay, sinubstitute lang natin to dito sa equation natin. Now you can see lahat ng ating terms is having dt. So this can be cancelled out, no? We are just going to factor out dt and it will be cancelled out. So ano yung may iwan sa atin dito? What we'll have here is Cp is equal to Cv plus R. Okay, so this is the relationship that we need to take note. Okay, and now we're going to apply itong ratio na kinuha natin. Now, we know that our K is equal to Cp over Cv. So, substituting that dito sa ating equation, you will actually get Cv is equal to R over K minus 1. And our Cp is equal to Kr over K minus 1. So, we also need to remember these relationships, no? This one and this one. So, we have to take note of all this. Okay, so now, itong nilagpasan natin kanina, no? Paano natin nakuha yan? So, internal energy of an ideal gas. So, delta U, ito muna kunin natin because we are looking for internal energy on an ideal gas. Okay, at constant volume process, so let's say we have constant volume process. So, sabi natin kanina, at constant volume process, our specific heat is Cv, di ba? And with that, we have our Q is equal to mCv T2 minus T1 or delta T. Okay? Now, according to the first law of thermodynamics, our U is equal to Q minus W, where W is work, which is equal to the integral of PdV. So, we have our du is equal to dq minus the integral of from 1 to 2 PdV. Okay, so the integral of pressure times dV. But we have a constant volume process here, no? So there will be no change in volume. So this will be equal to 0. So therefore, at constant volume process, our delta U is equal to delta Q. Okay, so in that case, if delta U is equal to delta Q, therefore, our delta U is also equal to mCv/T2 minus T1. So this is equal to mCv/T2 minus T1. So ayan yung ginamit natin kanina doon sa itaas. Okay, so this is applicable at constant volume process. So paano naman itong delta H? Okay, so let's say naman we have here for enthalpy for ideal gas. So let us say now that we have a constant pressure process. So we have constant pressure. So at constant pressure, our specific heat is Cp, di ba? Yan yung kaninang in-explain natin. Okay, so in that case, our Q is equal to mCp/T2 minus T1. Okay, so yan yung naandito kanina sa itaas. Okay, here, at constant pressure. Okay, so sinulat lang uli natin dito. Okay, now, by definition, our enthalpy H is equal to U plus PV. Yung kaninang pinakita natin, ano? Okay, so differentiating this, we have delta H is equal to delta U plus our PV, no? The changes in pressure in volume, we have P2V2 minus P1V1. Okay, so let's say this is our equation number 1. Okay, so now let us go back to our first law of thermodynamics. Ginawa na natin to kanina, no? So let me just write again this one, itong point na to. Okay? So let me write that again dito sa ibaba. So we have our delta U is equal to delta Q minus the integral of P dV. Okay, so rearranging this because we are interested to our Q here. So we have delta Q is equal to delta U plus 1 to 2 P dV. Okay, so basically this is Q is equal to delta U plus P2 V2 minus P1 V1. And as you can see, this is actually the same as our equation number 1. Okay, so pareho lang, no? So therefore, our delta H is also equal to delta Q, our Q here. So therefore, if our delta H is also equal to Q, therefore our delta H is also equal to this one, our Q here, MCP. Okay, so MCP T2 minus T1. And that is what we use there sa nauna nating pinakitang relationship, no? Itong delta H is equal to MCP T2 minus T1. So they are just the same. Okay? So we basically derive na itong mga importanteng equation na kailangan nating matutunan in working with specific heat. So let us now try to solve this problem. So for a certain ideal gas where R is equal to 25.8 feet pound force per pound mass per Rankine and K is equal to 1.09. So as you can see, no, given yung ating K, ito yung sinasabi ko, ratio ng CP over CV. Then we need to know A, what are the values of CP and CV? Okay, so makikita na ninyo yung relationship, no, kung ba't kailangan nating makuha yung ratio and yung kaninang binigay natin na relationship sa R ng ating CP and CV. Dahil kailangan talaga natin yan in order to solve yung mga problems na may kinalaman sa specific heat. B, what mass of this gas would occupy a volume of 50 cubic feet at 75 psia and 80 degree Fahrenheit? Then C, if 30 BTU are transferred to this gas at constant volume in B, what are the resulting temperature and pressure? So let us try to solve this problem. So we'll have our solution in here. So unahin natin yung A. Okay? So for A, we need to solve the values of CP and CV. So kung natatandaan ninyo, isa sa formula natin is ito. Sinulat natin. For CP, this is equal to KR over K minus 1. So you can use any of the two, but I will be using this one. So I will have CP is equal to KR over K minus 1. So let me substitute yung mga values natin. So we have our K, which is 1.09 times R. Our R is 25.8. Okay? Okay, so I will not be writing the unit because obviously ito lang naman yung unit natin. So yan din yung magiging result, no? For K minus 1, I have 1.09 minus 1. So ano yung magiging sagot natin dito? Let us use our calculator. So we have 1.09 times 25.8 divided by 1.09 minus 1, so 0.09. So we have 312.47. So 312.47, and our unit is in feet pound force per pound Rankine. Okay? And as you can see, medyo mahirap tong i-handle, ano? So, makikita naman natin dito sa ating C, it is expressed on BTU. So, better na i-convert na rin natin to sa BTU. No? So, in order to convert that, alam natin dapat yung ating conversion factor. So, we have, for every 1 BTU, we have 778.169 feet per pound. Okay, so yan yung ating conversion. So, this will be cancelled out, itong feet pound. Okay, so may iwan is BTU per pound per Rankine. Okay, so we're going to use our calculator again to convert. So we're just going to divide this by 778.169, and this is equal to 0.4015. Okay, so we have 0.4015 BTU per pound Rankine. Okay? So, yan na yung ating equation. Now, alam na natin yung CP, but we don't know what's the value of CV. So, alam natin that K is equal to CP over CV. So, therefore, makukuha na natin yung CB because our formula will be CB is equal to CP over K. Okay? So, our CP is 0.4015. Then, our K is 1.09. So, therefore, our CV, okay, is equal to, sagot natin kanina, 0.4015 divided by 1.09. This is equal to 0.3684. And our unit is in BTU per pound degree Rankine. Okay? So now, sagutan na natin yung B. Nakuha na natin yung A. Ang hinahanap natin sa B, what mass of this gas would occupy a volume of 15 cubic feet, a pressure of 75 psia, and a temperature of 80 degree Fahrenheit. So basically, nakikita na natin, we need to use the ideal gas equation. PV is equal to MRT. Okay, so given yung volume is equal to 15 cubic feet. Our pressure is equal to 75 psia, and our temperature is equal to 80 degree Fahrenheit. So we need to add 460 to convert that to Rankine, diba? Okay, so that means our temperature is 540 Rankine. Okay, so we have here our M, which is equal to PV over RT. Okay, so our pressure is 75 psia. Then our volume, which is 15 cubic foot over our R. So we have 25.8. Okay, yan yung given kanina sa taas. 25.8 feet pound. Okay, so feet pound per pound Rankine times 540 Rankine. Okay, so let's check our units. Okay, so Rankine will be cancelled out. Feet will be cancelled out. I will have 2 here. This is pound per square inch. Okay, so that means we need to convert that. No? So for every 12 inch, we have 1 feet. And we will be squaring that. Okay, so as you can see, this will be in square foot. So this will be cancelled. And our inches will be cancelled out from PSIA. And then this will be cancelled out from PSIA as well. So ang may iwan sa ating unit is in pounds. Okay, so I will have here our mass will be equal to, let us use our calculator now to solve this. We have 75 times 15 times 12 squared divided by 25.8, then divided by 540. Okay, so we have 11.63. Okay, so we have 11.63 pounds. Okay, so this is our answer for letter B. Okay, so hindi natin na-box kanina yung mga answers natin sa A. So let me box that. So this is CP. Okay, so this is our answer. Dahil ang pinahanap sa atin is CP and CV values. Okay, so nakuha natin yan kanina. So ang kailangan na lang natin makuha ngayon is yung letter C na, no? Nasa letter C na tayo. So for letter C, ano yung kailangan natin kunin? If we have 30 BTU transferred to this gas at constant volume, okay? So take note, constant volume tayo rito. So therefore, our specific heat is on CV. Okay, what are the resulting temperature? Okay, so we are at constant volume, so therefore we will be using Q is equal to mCV T2 minus T1. Okay, so we have 30 BTU for our energy. Okay, then nakuha na natin yung mass natin, which is 11.63 pounds. And CV, alam na rin natin yung value ng CV, nakuha natin dito, 0.3684. So we have 0.3684 times, we do not know T2, minus T1. We have our temperature here, T1, which is 540 Rankine. So we have 540. Alright, so therefore our T2 is equal to 30 BTU over 11.63 pounds over our CP 0.3684. Ano nga yung unit nito? Ating CP. BTU per pound per Rankine. So, BTU per pound per Rankine. Okay? And then, we need to transpose itong ating temperature. So, plus 540 Rankine. Okay? So, our T2 is equal to, let us use again our calculator. We have 30 divided by 11.63 divided by 0.3684 plus 540. So our temperature is 547 Rankine. Okay? So this is our answer for letter C. Pero kailangan pa rin natin makuha yung pressure. So paano natin kukunin yung pressure? How do you think we can solve that? So this is very easy because we are dealing with ideal gas dito sa ating assumption, ano? So therefore, if we have constant volume katulad nung naandito, so therefore we will have P2 over T2 is equal to P1 over T1. So kung gusto natin makuha what's the value of P2, so we have P2 is equal to P1 times T2 over T1. Okay, so substitute natin yung mga values natin. Our P1, our pressure initially, meron tayong 75 psia. Okay, so we have 75 psia times temperature 2, nakuha na natin, 547 Rankine, divided by our T1. Our T1 is 540 Rankine. So, 540 Rankine. So, therefore, our P2 is equal to 75 times 547 divided by 540. So, our P2 is equal to 75.97. So, we can say this is 76. No? 76 psia. So, this is our final answer here. Okay, so, as you can see, nasagutan na natin lahat ng mga requirement natin dito sa problem 3. And we already discussed yung mga kinakailangan nating matandaan in dealing and studying specific heat for thermodynamics and physical chemistry. So, I hope you learned a lot dito sa ating topic for today. Thank you very much and have a nice day. To watch more of our lecture videos about engineering and STEM subjects, please subscribe to our YouTube channel and click on the notification bell para lagi kayong updated sa mga videos na i-upload namin. We are regularly uploading tutorial videos in engineering, mathematics, chemistry, physics, at iba pang subject na magagamit ninyo sa inyong pagre-review. So, thank you very much sa patuloy ninyong pagsuporta sa enginerds.org.